So commonly, you can see limits on this form. This notation, limit as x approaches 0 of a function is equal to some number. And this simply means that if you have a function, any function with respect to a variable, let's say 1 over x for simplicity, and just for example, the answer to this is just the number that if you plug in this here, the numbers nearest to 0 from the left or from the right. So let's say this is the number line. This is 0, this is 1, and this is negative 1 here. So the numbers that are very, very close to 0. So those are the numbers you will plug into this x. And you will notice that all of those numbers will converge into a single number or will approach a number. So that would be the result of our function, or that would be the sum number. Sum number. So this number is only the y, or the f of x, if you plug in some numbers. To show you what a limit specifically is if we have the graph of y equals x squared, and if we want to study the coordinate x equals 2. So this is our x, right? This horizontal here, and this is our y, the vertical. So notice what happened as we approach 2. So as we approach 2, our value pretty much, or the y value, approaches 4. So that's just what a limit is. So if our function is y is equal to x squared, and we plug in 0.9 there, it will give us a result 3.999 or something. And from the right, so from 4 to 2, if we plug in 2.01 to there, it will give us 4.001 or something. And that will tell us that those numbers converge a specific y value, which is 4. So that's just what limit is. So if we draw that again and have a notation, the limit of our function, so our function is x squared. As x approaches positive 2, we get 4, right? Because if we take a look at the graph, this is the graph here. And if this is 2 here, here, and this is 4. So notice that if we plug in values very close to 2, let's say from the right, let's put arrow here 0.5, so that's from the left of 2, 1.5, and then 1.99, then this is 2 right here, and here from 2.5 to 2.01. So let's try, and what happens? The answer would be, I will assure you that it's 4. It approaches 4 as well. So that's if our x approaches 2, our y approaches 4. That's just what limit is. So let's try. So we plug in 1.5. So we square 1.5. That is 2.25. So this is 2.25. And now if we square 1.99, will give us 3.9601. So that's very close to 3.9601. That's very close to 2. So we don't care actually with the value what's on 2, because we're not actually getting into 2. But we care what happens as we approach 2. So that's the idea. So again, if we again go very close, so 1.999999, so that's 24689 times 1.246. So you can see that it's 3.9999, very close to 4. And if we have 2.0000001 times 2.0000001, it's very close to 4. So with that, we can conclude that as the limit of our function x squared approaches 2, it converges into y value, which is 4. So that's just what a limit is, basically. And the reason why limits is introduced in calculus because it's the idea behind approximating a slope of a curve from a secant line to a tangent line. So that's how important limits is, because we can now have or solve the slope of any curve we want by the idea of limits. Because back then, they don't have the tool to solve for the slope of a curve. They only know how to solve the slope of a line. Because we know that the slope of a line is just the rise and the run, or the change in the y over the change in the x. That's just what they know. But as time goes by and they finally manage to invent calculus, thanks for Newton and Leibniz for independently inventing it, they have now come up to a very genius idea, wherein they let a line passes to this curve or to a curve and call it secant line. So secant line is a line that touches a curve at exactly 2 points. So since that is a line, that's easy to find the slope of that. And the idea they come up is through the limits. So what if the run counterpart, or the change in x of the secant line, approaches 0 or approaches unitless or dimensionless? So that's the idea. What if it approaches 0? So by that, as this secant line approaches, the run of it approaches 0, it now become a tangent line. So all these lines that are tangent to a curve is the idea of calculus. So that's the slope of a line at any point on that curve. So ano man day, what's the big deal if we know the slope of a curve? If we know is the reason is if we know the slope of a curve, we know the rate of change at an instant. So let's say the real life application is if there's a falling leaf from a tree, we know that at the instant it falls, or let's say 5 seconds after that, we can know what is the exact velocity of that leaf as it falls. That's because of calculus. We can now solve for the instantaneous at that instant. So that's just one application of calculus, and there's a lot more.